Hello, 12th standard students. In our previous class, we have studied about the TCP/IP protocols, where we have understood the concept of transmission control protocol over internet protocol and how these are very important for the transfer of data from one computer to another. So, in before beginning today's class about IP routing and the further concept, let us once again we see the concept of TCP/IP and how it works to break the data and send it in a network. I've made these notes for you that TCP, also known as Internet Protocol Suite, is a collection of communication protocols that use the internet to send and receive data. A protocol is a set of rules that computers use to communicate with one another, and internet communication is found on the transmission control protocol and internet protocol. Each performs a different steps in the process of transferring data. TCP prepares the data by breaking it down into smaller pieces of information called packets, while also defining and maintaining the network connection. IP deals with the sending and delivering of the packets from one computer or server to another using a web of routers in a process known as IP routing. Once the packets reach their destination, it is the job of TCP again to reform their into their original state. This is how, through a diagram, now we'll understand that if any data, here we are taking it as in like an image, if for example this image has to be sent from computer A to computer B, which is in another network, so how it will be transferred, that first of all this image will be broken into a smaller parts and they will be called packets, and this packet will be routed by the router using IP routing methods, and when it reaches to the different network and when it will reach to the destination computer, all the packets will be arranged and will be the final output will be formed in the destination computer. So here the breaking of a data and assembling of a data is done by the TCP, transmission control protocol, where IP is responsible for routing those packets through the different routers from one network to another. Now here we again look at the working of an IP address that we have studied in the previous class, that how will it work. So in order for the packets to be sent to the right location, the router needs to know the location of both the source and the destination IP addresses. A unique 32-bit label assigned to one device. This address is split into section of 8-bit section, also called octet, separated by a dot from 0 to 255. So we have to see that the when this IP is made into 32-bit of 4 octets, it should not exceed 255. So 255 is the maximum number that we can allot to a one octet because it is of 8-bit each. The 32 bits are divided into two categories, a prefix and a suffix, where the prefix is a network ID and the suffix is a host ID. The prefix identifies the network to which the computer is attached. For example, an organization may reserve designated IP address such as 12.0.0.0. The suffix is a unique identifier for a computer on the network. For example, 12.52.128.194. The size of each suffix and prefix is dependent on the class of IP address. Here, what this definition is trying to say is that these 32 bits are divided into two categories, a prefix and a suffix. Here we can see a prefix, This is an IP address where it has got 32 bits and 4 octets of 8 bits each. And in a class A definition, the first octet is a prefix, and another third, the next 3 octet will be the suffix. It will go like in class B, the first 2 octet will be prefix and next 2 will be the suffix, where I've already told you that prefix means the network ID and suffix means the host ID. In class 3, the first 3 octet will be the prefix and the last octet will be the suffix. Class D and E, as told earlier, is used only for the multicast addresses and reserved for some very highly complicated and research works. So usually we use this A, B and C classes for IP addressing. So this is how a IP address is given or it works. Next, let us see how this class range is given to a IP addresses. The first class A has a range of 126 for a network and rest 3 for the host ID. So it has a range from 0 to 126. The class B, the range starts from 128 bit to 191, and the next 2 is left for the host ID. In class C, the range starts from 192 to 223. D starts from 224 to 239, and E, the ranges starts from 240 to 255. And here again we know that we cannot exceed 255 figure. Here in your textbook you have to do a correction that the range for the class A is 0 to 126, because 127 is again kept as a reserve and for reverse side is. So the range here is from 0 to 126, not 127. And the other ranges are correct: 128 to 191, 192 to 223, 224 to 239, and in class E 40 to 255. Now let us continue with the IP routing. So routing is a process of selecting path for traffic in a network or across multiple networks. IP routing is the process of transporting data from source to destination on a determined path across 2 or more networks. IP routing provides the path for reaching the destination devices. IP routing enables 2 or more devices on different TCP/IP networks to connect with each other. It is implemented, operated, and managed by the router, and its types are static routing and dynamic routing. Let us understand this IP routing through one of our notes. Here it says IP routing describes the process of determining the path for data to follow in order to navigate from one computer or server to another. A packet of data transfers from its source router through a web of router across many networks until it finally reaches its destination router using a routing algorithm. The routing algorithm takes into account factors such as the size of a packet and its header to determine the most efficient route to the destination. When a packet has reached a router, the source and the destination address of the packet are used in conjunction with the routing table, which is a list that contains the routes to a certain network, to determine the next hop address. This process is repeated for the next router using its own routing table until the packet has reached its destination. Because the data is divided into packets, each packet travels independently from each other and is treated as such. As a result, each packet can be sent through a different route to a destination if necessary. So here we can see a data from a network, from computer in a network A has to be sent to the computer B in network B. So IP routing will see that once the data is sent from a computer from network A, then from one router to another router, and another to another router. So this the packets which was made of a data from a computer A is routed through different routers and then sent to a network. So this network A and network B's address is given in the first octet of a IP address. If we are using uh, class C IP addressing, for example, so the first three will be going to see the first three octet in a IP address is going to see the network part, and the last one will be the computer's host ID. So this is how a IP router processes or it works. Now regarding the types of routing, we have just studied that there are two types: static routing and dynamic routing. So what is the difference? So just study the static routing definition. Static routing or non-adaptive routing follows user design routing, and routing table is not changed until network administrator changes it. Static routing use simple routing algorithm and provides more security than dynamic routing because no changes um, can be done in a static routing. Whereas dynamic routing or adaptive routing, as name suggests, changes the routing table once there is any change in a network or um, network topology changes. During network change, dynamic routing sends a signal to router, recalculates the routes, and send the updated routing information. So it means static routing. When we are talking about static routing, the routing remains the same. No matter whatever happens, it will going to follow the same routing protocols. Wherein dynamic routing, the routing will be changed according to the network topology or if there is any change in any sort of routing table. Further, I have made a differentiation table between the static routing and the dynamic routing, and there are different keys over which we can differentiate these two different types of routing. So let us study about the first key, which is the routing pattern. As mentioned that it is user defined, and in dynamic routing it changes according to the it is a dynamic routing, so it routing takes place automatically. Second is routing algorithm. No complex algorithm is used because it follows the simple protocol. Whereas in dynamic routing employ complex algorithm to find the shortest route for a data transfer. Next is security. Static routing provides higher security because it is following the strict protocol, whereas in dynamic routing, because of some changes, it became less secure. Automation. Static routing is a manual process, and dynamic routing is automatic process. Next is applicability. Static routing is used in smaller network, whereas dynamic routing has to be used in a larger networks. And next is about protocol. Static routing may not follow any specific protocol, and whereas dynamic routing follow protocols like BGP, RIP, and EIGRP, about which we will study in our later videos. Additional resources like static routing does not require any additional resources, whereas dynamic routing requires additional resources like memory, bandwidth, etc. Link effect. If any link between routers fail, it disturbs other routing paths, whereas failure of any link between routers does not affect other routing paths in dynamic routing. Lastly, the routing algorithm. It does not use any complex routing algorithms, whereas it uses complex routing algorithm when we talk about a dynamic routing. So this is a differentiation between a static routing and dynamic routing. So that's it about today's topic, and I hope you have understood something, and you just watch this video over and over to understand more clearly, and see you in our next class. Thank you and stay safe.